Hi everyone. In Unit 5, Introduction to ASIC, we are going to see the next topic is combinational logic cell, sequential logic cell, and data path logic cell. So, okay. Already we have discussed this topic in Unit 2 itself and Unit 3. So, whatever concept we discussed in Unit 2 and 3, that it should be accumulated here. Okay, and we know that combinational logic cells in the form of AOI and OAI logic, that is AND OR inversion and OR and inversion, represents 2 to 1. It's what each gate having an input. So in this first circuit, A, B, C, D are two inputs and E is the another output. Okay, so each gate having two inputs, so that represented by 2 to 1. Initially both the inputs are getting odd, and after that it's odd, and finally it's getting invert. So that is the name called AND or inversion. Whereas in OAI, here first gate has a 3 input, so 3, and second gate has a 2 input DE, and final is 1. Here OR and inversion happens. Okay, so this is simple combinational logic cell. Getting the equations like this, and bubble pushing. So in this case we are getting bubble at the end of the result. Okay, end of the last gate. Okay. Here it's not like that. We are giving input itself we have bubbled, so no need of taking at the end of inverter. So that is, here bubble pushes to the inputs. Okay, so here output in Z bubble, it's pushed into the input, and for R and R, which is the parallel, and which is in a series, that we know from the static CMOS design. Okay, and so that is connected through ABCD schematic design, and it should be both PMOS and NMOS transistor. Okay, and bubble pushing, it's happened from inverter output to input. And sequential cells, sequential cell we may have a latch and flip-flop, right? Whereas in sequential combination we have seen a simple logic gate. Here we may see the latch. This circuit already I have discussed in Unit 2, master slave triggered latch. Okay, so in this transmission gate based transmission latch, this one. Okay, and latch is transparent. The first circuit, which it tells how the latch will work. When your clock is high, your data is transferred, right? When clock is low, if it is a positive level trigger or negative level trigger, so based on that level trigger, your latch will transfer your data from input to output, right? So like that, the D is transparent in D latch. So when there is no connection between D and Q, it should be in a loop, that's a stored loop. Okay, that is happened in the C, where A is the complete transmission gate diagram, and B diagram, which tells about latch is transparent. When I3 is not connected to D and I2, which D, whatever data is D, that is directly transferred to Q. Whereas in figure C, D is disconnected with the Q, and whatever the data previously stored, which is to be latched. So that is the logic behind the sequential cells. And the same thing, it's a flip-flop. The same structure is cascaded by 2 times. Okay, the same structure is cascaded by 2 times. So that is flip-flop. So positive edge triggered and negative edge triggered flip-flop. Here they have shown a negative edge triggered flip-flop. So according to that, it is structure is connected. Okay, that combinational logics, these are all the circuit which is available in the data path between one source to destination path. Okay. So combinational cells, AOI and OAI logic, and sequential cells have to talk about latch and flip flop. Thank you.